Okay, so in this video we're going to talk about special right triangles, and the first one that we're going to talk about is a 45, 90 degree special right triangle. So here's the deal with this thing. The special right triangle, which has a measure of 45, 45, 90, has a specific ratio. If this side and this side are both going to have the same length because, well, you've got a 45-degree angle, so since the angles are the same, the opposite sides are going to be the same. And then if we do the Pythagorean theorem, we can find that we have a squared plus b squared equals c squared, and this is side A, and this is side B, and this is side C. So we know we have x squared plus x squared equals c squared. Alright, so I have x squared plus x squared equals c squared. So that gives me 2x squared equals c squared. But I don't care about c squared. I want to know what c equals. So what I need to do is I need to take the square root of both sides. Normally when I take a square root, I'm going to take both the positive and negative square root. But since I can't have a side length of it with a negative number, I don't have to do that here. So what happens is I have the square root of 2x squared equals c, and then that tells me that I have the square root of x squared times the square root of 2 equals c, and the square root of x squared is just x times the square root of 2 equals c. So c equals x square root 2. Okay, so what does all that mean? Well, any number, let me say it this way, if I know the side of a 45-45 right triangle, I know all sides. So let's say, for instance, that I've got, I don't know, say that this side is not x anymore, but it's 2. So if this side's 2, then we know this side's 2, and this side is now no longer x square root of 2, but 2 square root of 2. Great. Let's keep going. What if we have, let's say we have this side is 3. Well then, this side is going to be 3. And that means this side is going to be 3 times the square root of 2. Well, what if we know the hypotenuse and we want to know the sides? What can we do? Well, let's see. What if we said that C was 4? Well, we know that we have this relationship, that this side is going to be x, and this side is going to be x root 2, and this side is going to be x. So to go, if we know the hypotenuse and we want to know a side, all we need to do is divide by the square root of 2. So that means that side B is now going to be 4 divided by the square root of 2. But as you know, we cannot have a square root in the denominator, so we multiply both sides by the square root of 2, and then that gives us 4 root 2 over 2. 4 divided by 2 is 2 times the square root of 2. And so since this side is 2 times the square root of 2, this side has to be 2 times the square root of 2. Let's do a couple more examples real quick, just so I can make sure that you got it. Let's say that, this time the hypotenuse is, I don't know, say 20. No, let's not use 20 since I just used 2 or 4. Let's do something that's an odd number, say, I don't know, 5. Okay, so we're going to we're going to divide 5 by the square root of 2. So 5 square root of 2, multiply the top and the bottom by the square root of 2, and then we're going to get 5 root 2 over the square root of 4, which is really 2, so we have 5 root 2 over 2. And if B is 5 root 2 over 2, then A is also 5 root 2 over 2. And that was special right triangles, 45, 45, 90. Stay tuned for 30, 60, 90, which has a completely different relationship.